Hello Rockstars, I hope you're all doing amazing. Welcome to today's session of SCMP Shield. We're discussing the chapter Lean System and Innovation. So it's your journey. Sometimes it is going to be hard, but believe me, it's not impossible. So many people have done it already. You have the strength within you to achieve that. So just keep going. We will together reach that destination that we've always dreamt of. So we're discussing the chapter Lean System and Innovation, and we are going to start with a new topic, which is cellular manufacturing. It is also called as one-piece flow production system. So what is it? Yes, we already have an idea of what cellular manufacturing is. We've already discussed this concept in the concept of just in time. We have told the concept of grouping machines into working cells. Same thing is also called as cellular manufacturing. So let's see what it is all about. First, let's begin straight away with a small example to understand practically how things are going to work. Yes, students, so traditionally how manufacturing was happening. Okay, suppose there are 5 machines. We will arrange them one by one. Okay, in a row. Say for example, we have 5 machines, machine 1, 2, 3, 4, 5. We have arranged them in a row. This is how the factory layout would look like. Say for example, we want to manufacture 2 products. Yes, we have product 1, which requires the usage of machine 1, machine 3 as well as machine 4. We also have product 2, which requires the usage of machine 2 and machine 5. So what we generally do, yes, a raw material to produce the first product, say product X. Okay, raw material has come here, processing will happen at the end of machine 1. Whatever the work in progress we get, now it has to be transferred to machine number 3. So what we'll do, we'll be having employees, yes, who will manually come, who will transfer it to the third machine. Is it clear? So again, from third machine, again it will go to fourth machine. This way our finished goods is produced. Assume this is finished good X. Now what is happening? Yes, we are having unnecessary waste in our manufacturing process. Yes, our waste, tin wood. So unnecessary transportation cost is there. Unnecessary motion, unnecessary movement is there. Unnecessary waiting cost could be there. Again, we don't know. See, machine 1 is here, machine 3 is here. We don't know whether machine 3 is right now available or not. So whatever we produce right now, yes, it may be possible that the machine 3 is not available. It is producing something else. So it has to wait for some time. So waiting time, all of that could be possible. Yes. Again, to produce product 2, say for example, product Y, raw material should first go to machine 2. Yes, from here all the way, employee should move this to machine 5. So what cellular manufacturing is telling? Yes, cellular manufacturing is telling, yes, let us try to come up with a new model, yes, wherein we divide our factory in the form of cells, different cells, yes, having U-shaped design. So what is going to happen? Say for example, this is my factory now. So what I have bifurcated this as? I have bifurcated my factory in the form of 2 different cells. In cell number 1, I am producing my first product X. In my cell number 2, I am producing my second product number Y. Now, what is going to happen? Yes, raw material to produce the first product. Yes, it will directly come here. So if you have implemented just in time, what will happen? My supplier will straight away bring to that specific machine which is going to use that product. Now it is simple because we know the cell, which cell we want that. So you can straight away come, drop it here. So he has dropped the machine here. From here we process straight away. Generally there will be conveyor belts through which automatically goods will pass from there to here. Okay, we've reached machine 3. Here again we have processed. It will go to machine 4. Generally what will happen? All the finished goods which are prepared, yes, they'll be having a space to store. Okay, so after some time, once all the goods are produced, what will happen? All the goods will be sold straight away. Yes, this way what we are trying to do, we are trying to avoid all the wastages that used to previously happen in our production process. So firstly, motion time is reduced, unnecessary motion, unnecessary movement is reduced. Second, unnecessary transportation is reduced. Thirdly, a supervisor can quickly identify, yes, where what is happening. Yes, which machine is having a problem. If the speed is not synchronized, which machine is having a problem, that could be quickly identified. Again, previously what used to happen? Suppose I want to manufacture 1000 units. It's not that every unit I will produce 1 unit in machine 1, I will transfer to machine 3. What I used to do, 1000 units in machine 1 I used to produce, then all the 1000 units I would transfer to machine 3. So if any defects are recovered, if any defects are identified, yes, that defect would be there on all the 1000 units. But here what is happening? Because they are close by, So we produce 1 unit here. The moment it is happened, it transfers to machine 3. Yes, it goes to machine 4. So if at all any defects are there, that will be quickly identified. Again, supervisor will be there. He can quickly supervise what every person is doing, whether every person is efficiently working or not, whether they are motivated or not, whether any machine is having an issue. All of that could be identified. Again, if any machine, any cell is having an issue, it will impact only that cell. Other cells can keep working. Yes, all these things we had already discussed, students. So already discussed in the concept of just in time. Just in time, we've discussed Kanban card as well as working cells, grouping your machine into working cells. Same concept. Yes, we are going to take it to a next level. There we have told we have to bifurcate it as a working cell. Now here we will tell how do we bifurcate it as a working cell. All those things will come into picture. So first, let's have a look at the basic discussion on cellular manufacturing. So, basics of cellular manufacturing. So, what is it? It is a process of manufacturing where machines are grouped into cells or clusters. Why are we grouping them? So that goods can be moved as quickly as possible and waste gets reduced. Two objectives. First, we want to reduce the waste, whatever waste is there in the production process. Second, the movement of goods should be as quick as possible. So for that, our complete manufacturing process, we are bifurcating in the form of cells. So generally, what will happen is the complete, say for example, this is our factory layout. Okay, previously how it was there, all machines were there one by one. Yes, in some order, some random order they were kept. Okay, now what they are going to do, they are going to bifurcate it in the form of a cell. Say for example, here we have cells, this way U-shaped cells. Again, here we will be having cells. So yes, things are going to look clean. Again, movement will be minimum. Again, if supplier wants to give me any raw material, otherwise he has to, yes, look around. Yes, go so many places. Now straight away, yes, clean place is there. Wherever cell, whichever cell he wants to give, he can do that quickly. Okay, yes, this is cellular manufacturing. Yes, in a cell, machines that are necessary to produce a product or service are grouped in a systematic order. Whatever machines are required to produce a product, yes, they are arranged in a systematic order. Cells will be generally given a U shape because it allows the supervisor to move less and supervise the entire process. Yes, if it is in a line shape, yes, he has to keep moving here and there. Again, it may be possible if it is like very lengthy, he may not recognize where what is happening, what employees are doing. But if it is in a U shape, yes, he can quickly recognize, understand everything. Yes, what every person is doing. So that is the benefit of having a U shape. Now, goals of cellular manufacturing: move as little as possible, manufacture a wide, it's not a wild, it's a wide range of similar products. What is it, students? A wide range of similar products. What we are telling? A wide range of similar products. Similar products. Suppose we are manufacturing cars. Okay. Suppose we are manufacturing cars. Previously, what used to happen? Yes, we could manufacture only one color car or only one standard feature. We cannot go for, yes, one level upgradation, one level down. Now, if we go for cellular manufacturing, what we can do? Similar products only, cars only, same model car. Say for example, we want to produce Vitara Brezza. Same product, but a wide range we can give. Okay, some different colors. Okay, yes, one with a rooftop. Also, no, what is it called? Sunroof, one without a sunroof. Okay, one with the extra airbags, one without. So, wide range, wide variety of same product we can do if we are implementing cellular manufacturing. Is it clear? And making as little waste as possible. So this was all the theory. Yes, what is important for you, if at all you have to write, yes, is this sentence. These 2 to 3 things. First, yes, how we are doing manufacturing? Yes, machines are grouped in the form of cell. Why are we doing that? So that goods could be moved as quickly as possible, waste gets reduced. Now, machines which are necessary to produce a product are kept together in a systematic order. Again, the cells will be generally given U shape so that supervisor can supervise, oversee the complete activity. Is this clear, students? Any doubts till now? Should we continue, everyone? Now, different types of cell designs could be there. Okay, so what are the different types of cell designs? So either we will be having only a single machine cell, or we will be having group machine cells with manual handling. or we'll be having group machine cells with semi-integrated handling, or we'll be having flexible manufacturing system. 4 different types could be possible. Now, to give you another example of cellular manufacturing, okay, it's not a perfect example, but still you guys can relate it better. Say typically in our CA office, how it would be there? Yes, we'll be having one cabin where all seniors will be sitting. Yes or no? Generally. Yes, again we'll be having 1 or 2 cabins for articles. Yes, typically this is how a proper arrangement would look. Yes, one cabin, yes, one segment for seniors. Yes, where they will be there, they will be discussing all of that. Yes, 1 or 2 depending on the number of articles, 2 different rows for articles. Wherein articles will sit, articles will work, all of this could happen. Now, if at all, yes, we are going on an assignment wherein one senior is there, 2 articles are there. Now, typically if you see their workplace, say this is how the workplace is going to look. Now, if at all they have to sit, they have to discuss, yes, they have to prepare a report, they need to look at the working, all of that they need to do. See, every time article has a doubt, he has to go all the way from here, ask him, again come all the way, do his working. Here, from here he has to go all the way here, do his working, come back here. So, what cellular manufacturing is telling? Now, who all are required to be together? Now, you can rearrange all the cabins in the form that, assignment wise, you can assign, okay, this is the senior, along with him for that assignment, whoever articles are there, they can sit together so that senior can supervise what articles are doing. Are they properly working? Are they wasting their time? Yes, he can tell whatever he wants to tell quickly, and at the same time waste, yes, that is movement time, unnecessary waiting time, all of that could be avoided. Is it clear, students? Yes, it was one more example wherein you could relate it more. Now, different types of machine cell designs. What all are the different types of cell designs? First, they are telling either it could be a single machine cell. That means, yes, there will be a cell in which we'll be having only one machine. Only one machine will form a part of a cell. When it will be used, students? When will a single machine cell design be used? Think and tell me. Yes, in a cell, we are having only one machine. That means to produce our output, to produce our finished goods, we want only one machine. Yes or no? We want only one machine. One machine is sufficient for us to finish our manufacture our output. Then we will tell, okay, create a cell using only that machine. Say for example, we are doing what we are doing. Say for example, we are grinding, okay, mirchi. You know how mirchi powder is made? What we call mirchi in English? Chili powder. Okay, how it is done? There is that grinding machine. Okay, just we'll take that. Okay, yes, it will go through that grinding machine. It will give you the powder. As simple as that. Only one single process is sufficient. Yes, so one machine. Yes, you do that grinding, you get the powder. Yes, you pack it. As simple as that. So one single machine could form a cell if that single machine is sufficient to produce your output. So it is a single machine cell. It consists of a single machine and its supporting tools and fixtures in a cell. It is useful for parts that can be manufactured by only one type of process. Okay, yes, if we have one machine, it is sufficient, our finished goods will be ready. Then create that machine in the form of a cell. Is it clear, students? Should we continue? Or else there could be group machine cells with manual handling. What we are telling? See, we have a cell number 1. In that, it's not a single machine. There are a group of machines, 1, 2, 3 or 4, whatever it is. Group of machines are there, and how we are handling, yes, between one machine to other machine. Yes, one machine's output will become next machine's input. For that, we need to transport. How is that transport handling happening? It is manually. There will be employees who, the moment we get output at the first machine, yes, they will take it to the second machine. Yes, they will work. At the end of second machine, again there will be people who will take it to the third machine. Yes, again at the end of third machine, they will take it to the fourth machine. It is manual handling. It consists of more than one machine to form a cell. Okay, material handling in between the machines is done by human operators. Human operators are doing that handling between one machine to other machine. Generally, in this case, U-shaped cell is preferable. In the first case, it was a single machine. Whether we had U-shaped, whether we didn't have U-shape, it did not matter, because ultimately it was only a machine. If supervisor had to supervise, he had to just supervise that one single machine and one single machine operator. So whether it was U-shaped, not, it did not make a difference. However, second, third, fourth, whatever cell designs are there, U-shaped cell would be preferable because it will help supervisor to oversee the complete activity. Is this clear, students? Should we continue? Yes, third, group machine cells with semi-integrated handling. What is this? Semi-integrated. It's not manual, but at the same time, it's not fully automatic also. Yes, so it consists of more than one machine to collectively form a cell. Again, same thing. We are having machine 1, machine 2, machine 3, machine 4. 4 machines are forming a cell. Now, how do we transport or how do we move the goods between one cell to other cell? Yes, we are using conveyor belt to move the part between cell, but it is not fully automated. Yes, we are having a conveyor belt through which movement of goods is happening from one machine to other machine, but it is not fully automated. I mean, to manufacture the goods in the machine, we want an operator. To run this machine, we want an operator. But once we get finished goods, from here to put it on a conveyor belt, we want an operator. But what conveyor belt does? From here till here, the movement conveyor belt takes care of. Is it clear, students? Yes. Do you guys know what a conveyor belt is? I guess all of you would have seen a conveyor belt, especially, either in a railway station. Okay, the moment you enter with your luggage, okay, they'll scan. For that, there will be something called as a black color through which you keep your goods. It will go automatically. Yes, or else in a metro station also it will be there. Sometimes it will be there in your mall entry also. Yes, if you would have gone to airport also it will be there. So that is a conveyor belt. So generally they'll keep a conveyor belt here so that whatever output I get, I will drop it here. From here it will automatically go to the next machine. From here the machine operator will pick, he will process, he will again put it on the conveyor belt, it will go to third machine, he will put, he will process, output he will transfer to fourth machine. This way things are going to happen. Is it clear, students? It is not completely manual. Yes, conveyor belts are there, but to put it into conveyor belt, to remove from conveyor belt, to operate the machine, all of that human intervention is required. Is it clear? It's not completely 100% automated. And finally, we have the flexible manufacturing system. What it is? Again, group of machines are there, but it is fully automated. It consists of highly automated machine cells in a group. They have highly automated and highly integrated material handling system. There is no need for any human intervention at all. Yes, the moment finished goods are prepared, there will be automatically robots which will pick it, which will put it in the conveyor belt. Again, in the next machine, there will be again robots which will pick it. Yes, again put it to specifically to the machine. Operation happens, output. Again, there will be robots which will pick, put it in the conveyor belt. So completely flexible, fully automated machine cells. Is it clear, students? So 4 things are there. Yes, 4 different machine cell designs could be there. Now I have given you the name which is given in ICAI only. So if you want, you can make things very simple. See, basically 2 things. Either you will be having a single cell design. Yes or no? Where you are telling one machine is sufficient. Yes, one machine alone will form your cell. Single machine cell. Yes. Or else you are going to tell, no, single machine is not sufficient. To form a cell, I want multiple machines. Yes, if it is multiple machines, we would be generally preferring a U-shaped model. Okay. Now in multiple machines, how is material handling happening? Either material handling will happen manually. Yes or no? There will be people, yes, who will pick from there, who will transport, yes, who will drop there, either manual, or it could be semi-automatic, yes, which is through conveyor belt. It is called a semi-integrated system. Semi-integrated or semi-automatic, or it could be fully automatic. Yes, fully automatic is also called as our flexible manufacturing system. As simple as that. Is it clear, students? So whatever terminologies ICAI has used, same thing I have told. But even if you change your words 1 or 2, instead of semi-integrated you use semi-automatic, it should also be fine. Okay, instead of writing fully flexible, yes, if you write fully automatic, should not be much of an issue. But whatever terminologies ICAI is used, I have also straight away used the same terminologies. Is this clear, student? Any doubts till now? So now let us move to one of the most interesting areas, rank order clustering algorithm. Yes, ROCA. It's also called as binary ordering. It is also called as King's algorithm. Yes, in this we are telling, yes, suppose we are having 10 machines, 20 machines, 50 machines, 100 machines, 1000 machines. How do we bifurcate them in the form of different cells? How do we arrange the cell? How do we find out, yes, how many cells we want? Yes, in every cell, which all machines will be there? Yes, which all parts will be produced? All of that we get to know using rank order cluster algorithm. Again, this is one topic which was recently added by ICAI. It was there in our May 22 RTP. Yes, again, some questions are there in our study material also. Additional question booklet also. We'll be covering each and every question. Believe me, students, this could be one of the most important topics from your examination perspective. Again, if at all a question comes, the question could be for 10 marks, the question could be for 20 marks as well. Okay, so let's first revise whatever we've discussed till now, students. So we are discussing the concept of cellular manufacturing. What is cellular manufacturing? Telling, yes, your manufacturing process right now you're doing in a traditional way. Yes, all your machines are haphazardly kept in an order. Yes, there is no ranking. Yes, there is no grouping. Yes, you do one thing, group your machines in the form of U-shaped cells. Why? So that our movement time could be reduced and our waste gets reduced. Ultimately, lean system is all about reducing the waste without sacrificing on productivity. So try reducing our movement time, transport time as much as possible. This way we can also try to reduce our waste and ensure goods are produced as quickly as possible. Yes, so cells will be generally in U shape because it allows supervisor to move less and supervise the entire activity. Again, we have seen the different types of machine cell designs. Either we are telling one machine is sufficient, or we are telling no, multiple machines are required. So either we are having a single machine cell or we want multiple machines, that is group machine. So in group machine, how material handling is happening? Either material handling could be manual, yes, that is employees are doing it, yes, or it could be semi-automatic, semi-integrated, that is with the help of conveyor belts. So transport happens to conveyor belt, but to put it into conveyor belt, remove it from conveyor belt, employees are required. Or it could be a completely automated system, yes, wherein using robots, all the material handling is taking place, we need not worry at all. Now we are moving into rank order clustering algorithm. So to bifurcate all our machines into cells, there could be different ways, different techniques. Yes, rank order clustering algorithm is one of the techniques. Is it clear? So you're going to enjoy it. First, there are too many steps, too many things are there. Let us straight away understand it with the help of a small example. Yes. So, example, find logical part families and machine groups based on ROCA and create part machine incident matrix. What is it? We'll understand. Now, it is telling P1 to P5. These are the products or the parts that we have to produce. So, we have to produce 5 different products. Okay. Now, to produce these products, how many machines are required? 5 machines are required. Machine 1, machine 2, machine 3, machine 4, machine 5. Now, what these numbers are telling, just pay attention to the students. Now, against P1, we have 1 in M1 and 1 in M3. It is telling that, yes, to produce my product 1, I have to use machine 1, I have to use machine 3. Is it clear? To produce product 2, I have to use machine 2, I have to use machine 4. To produce product 3, machine 4 alone is sufficient. To produce product 4, I want machine 3, I want machine 5. To produce product 5, I want machine 2. As simple as that. Now, typically, how will all the machines be arranged? Typically, what would be the arrangement of machine, students? Typical arrangement would be, yes, we have 5 machines. Let us arrange machine 1, machine 2, machine 3, machine 4, machine 5. So if you want to produce product 1, so raw material will go through machine 1, the output whatever we get, yes, has to go to machine 3. So human intervention, unnecessary motion is there. Again, product 2, it will go through machine 2. Again, from here it will come out, it will go to machine 4. Yes, unnecessary human intervention, again, because too many movement is there. Yes, there could be delay, there could be waiting. Okay, unnecessary problems, all of that could be there. Now, what we are telling, we have to bifurcate it in the form of cells. Now, without knowing rank order clustering algorithm, let us try doing things logically. How would we do it? Without any knowledge of ROCA. And then let us try getting the same answer using ROCA. Now, pay attention, students. Suppose I am telling, let me have my first cell. Cell 1. Whatever products I am producing and whatever machines that are required. Now pay attention. Yes, no formula, nothing. Straight away, pure logics. Yes, what we are telling? To produce product P1, what all we want? We want machine 1, we want machine 3. So what we want, students? We want all our unnecessary waste to be reduced. So we'll tell, yes, to produce P1, we want machine 1 and machine 3. So let us keep them together. So my machine 1 and machine 3, I will keep it together. Here I will tell, I have machine 1. Here I will tell, I have machine 3. Yes, in this, which product I have produced? Product 1 I have produced. Is it clear, students? Any doubts till now? Simple. Yes, we are not complicating anything. Yes, should we continue? Everyone? Okay. Now, let us go further. Yes, we want to produce the next product, product 2. Yes, for this we want machine 2. We want machine 4. So we have told, see, there is no link to the previous cell. Previous cell we wanted machine 1 and machine 3. Here we want machine 2 and machine 4. So let us do one thing. Let us create a new cell. Yes, wherein we will keep machine 2 as well as machine 4. Okay, I have created a new cell. Cell number 2. Yes, so here right now I have kept my machine 2. I have also kept my machine 4. So what product I am manufacturing here? I am producing product 2. Yes, what all machines are there, that also will write. Yes, till now things are clear, students. Any doubts? Now, let's proceed further. I want to produce product 3. Yes, to produce product 3, I want machine number 4. To produce product 3, I want machine number 4. That one machine is sufficient. So, where will I manufacture this product? In cell 1 will I manufacture, or I will manufacture it in cell 2? Tell me, students, where will I manufacture this? Will I manufacture product 3 in cell 1 or cell 2? I will manufacture it in cell 2 because I have my machine number 4 in cell 2. Is it clear? So I will tell, along with P2, you produce P3 also because machine is straight away available there. Okay. Now I want to produce P4. To produce P4, what all I want? I want machine 3. At the same time, I also want machine 5. Is it clear? Now, machine 3, is it kept anywhere, students? Machine 3 I have already kept in cell 1. Now to produce my product to 4, I want machine 4 as well. Which machine it is? Sorry, machine 5 as well. So what I will do? Anyways, machine 3 is here, right? So let me also arrange my machine 5 here. So that, yes, when I am producing product 4, raw material will come here. From here, it will go here. So I have my product 4 as well. Is it clear, students? So I have my machine 5 also. Here again I am producing my product 4. Is this clear? Now finally I have my product 5 for which I want machine 2. Where is machine 2 there, students? Machine 2 is available in cell number 2. So I will tell, I will produce my P5 here. Is this clear? So in cell number 1 I have machine 1, machine 3, machine number 4 where I am producing 2 products, P1 as well as P4. Yes, in cell 2 I am having machine 2 and machine 4. Yes, where I am producing 3 products, product 2, product 3, product 5. This is our final answer. This is how we are going to bifurcate our factory. This is how we are going to bifurcate our factory in the form of cells. Is this clear, students? Okay. This is machine 5. Yes or no? Yes, it was a small clerical error while writing. Now it has cleared. Okay. Yes. So, till here, any doubts, students? Till here, any doubts? Any doubts in this one? No doubts? Yes. So, the same answer we want to get using rank order clustering algorithm. See, when we have only 5 to 6 machine, it is simple. We can manually sit, we can do, okay, we'll group it here, we'll group it here. But when the number of machines are more, yes, think of a big organization like Tata Motors. Yes, they want to produce a car, they may want somewhere around 500 components. To produce that, they may be having somewhere around 200 machines. Now, how do we arrange those machines? To produce 500 components using 200 machines. How do we arrange those machines in a systematic way? This is what our ROCA, rank ordering clustering algorithm, is telling. So, Now pay attention, students. So first, okay, we are going to get the same answer using rank order clustering algorithm. So we have to write the same data. Okay. So I'm going to create tables, the same tables I'll have to keep creating. I'll keep getting my alteration. First, what I will do, I will write the same table. I've written down the same table, students. See P1, P2, P3, P4, P5, M1, M2, M3, M4, M5. All the data, whatever was there, whatever data is there in the question, I will write it down. Is it clear? No change. Whatever question has given me, I have written it down. I will explain you the steps now. We'll get the same answer. Then we'll again discuss in short what could be the logic why this is working. Okay. Now, so every table I will give a name. Okay. First table, every odd number table. Yes, you have to remember Cristiano Ronaldo. Yes, who is the best football player in the world? Who is number one in the world in football? Yes, don't fight. It is Cristiano Ronaldo, for the sake of getting the answer. Okay. So we are going to call it as CR table. CR table. C stands for column, R stands for rows. Yes. So what I am going to do? Yes, for my columns, I am going to give the weights. For my row, I am going to give the decimal equivalent. Does it make sense? No issues. We will explain now. Yes, just pay attention. Yes, which are my column? Is this my column or this is my column? Which is my column? This is my column or this is my column? Which one, students? Yes, this is my column. Yes or no? Yes, vertical is what my column is. For my columns, I have to give binary weights. Yes. So binary weight, what binary weight is? 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, so on and so forth. Yes, we'll make it very simple. Yes, I will write it as, yes, from last I will start. Okay, for the final product 5, I will give weight as 1. Then I will go on doubling. Yes, here I have given 1. Here I will make it 2. Here I will make it 4. Here I will make it 8. Here I will make it 16. Next, if there was one more, I would have made it 32, 64, 128, 256, so on and so forth. Is it clear, students? Yes, now I am just explaining the steps. What I have done? Yes, first table is my CR table. Yes, in that for my columns, I am going to give the weights. How I am going to give the weights? I am going to start from the end. Yes, that is from the last column. I will give 1, 2, 4, 8, 16, 32, so on and so forth. Yes, it could also be written as 2 to the power 0. 2 to the power 0 is 1. 2 to the power 1 is 2. 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16. Yes, all those complicated formulas are there in our textbook. Yes, it's not at all required. Just keep it in mind. Yes, I want to assign binary weights. Yes, how do I give binary weights? 1, 2, 4, 8, 16, 32, so on and so forth. From where I am starting? From the end I am starting. Not from, yes, start I am starting reverse. Okay, from end I am going to start 1, 2, 4, 8, 16, so on and so forth. Is this clear, students? Any doubts in this one? Should we continue? Okay. Now, I have done this to the columns. I need to do something to my rows as well. Yes, for my rows, I have to give my decimal equivalent. What is decimal equivalent? Again, we'll explain. Now, I am telling, yes, in machine number 1, what all products I am producing, students? What all products I am producing? In machine number 1, I am only producing product P1. What is the weight of P1? What is the weight of P1, students? What is the weight of P1 that we have given, that we have assigned? What is the weight of P1? Yes, the weight of P1 that we have assigned is 16. So here it is going to be 16. As simple as that. Is it clear? Now, in machine number 2, what all we are going to produce, students? What all we are going to produce? We are producing P2. What is the weight of P2? 8. We are producing P5. What is the weight of P5? 1. So 8 plus 1, how much is it, students? 9. Is it clear, students? Again, machine 3, what we are producing? P1 I am producing, whose weight is 16. P4 I am producing, whose weight is 2. So 16 plus 2 is going to be 18. Now, machine 4 I am producing P2, whose weight is 8. P3, whose weight is 4. So 8 plus 4 is going to be 12. And here it is going to be 2. Is this clear, students? Any doubts in this one? So first what I have done, students, my table number 1 is CR table. Yes, Cristiano Ronaldo. Yes, first columns. I am going to start with the columns. For columns, what I'm going to give? I'm going to give the weight. How I'm going to give the weight? Yes, from the end I will start. I will give 1, 2, 4, 8, 16, so on and so forth. Step number 1 over. Now, column is over. Now I need to do with the rows. Yes, for my row, what I need to do? I need to calculate the decimal equivalent. Based on the weight, what is the total decimal equivalent I need to calculate. So based on that, I've also done. So for machine 1, I just want P1, whose weight is 16. So it is 16. For machine 2, I want P2, whose weight is 8, P5, whose weight is 1. Okay, accordingly, so on and so forth, I've done. Is this clear, students? Any doubts till now? I want you guys to write it down also simultaneously. So giving you 2 minutes, just write it down, students. So what all we have done, students? Yes, it is our CR table. Yes, first for columns, I have given the weights 1, 2, 3, 4. Oh, sorry, 1, 2, 4, 8, 16. Yes, then against that, for my rows, I have calculated my decimal equivalent. Two things I have done. Third, I have given my decimal equivalent, right? Based on that, let me give the ranking. Where am I having the highest value? Where am I having the highest decimal equivalent? Yes, it is machine 3. For this, I will give rank number 1. Second best, rank number 2. Third rank. Fourth rank, fifth rank. Is it clear, students? So look at the table. Yes, everything is there in the name of the table that we have given. Yes, it is my CR table. Yes, first what I have done, for my columns, I have given weights. Okay, then what I am going to do? Yes, based on the weights I have given to columns, for my rows, I will calculate decimal equivalent. Okay, I have done that. Yes, based on that, I have calculated decimal equivalent. I will give a rank to the rows based on the decimal equivalent. And finally, now what I am going to do? I am going to rearrange the rows. Yes, now pay attention. Yes, this table is there. I am telling, now I need to rearrange. What I need to rearrange? I need to rearrange my rows. How? Yes, my first ranked row, I will write it on the top. My second ranked row, I will write it in the second row. Yes, third ranked, yes, machine, I will write it in my third row. Fourth rank, I will write it in my fourth row. Fifth rank, I will write it in my fifth row. Columns will remain intact. Columns will remain the same. Only the row ordering I am going to change. Now pay attention, students. Yes. Yes, so which is my first rank thing? Now pay attention. My columns will remain intact. So first, in the next table, okay, I have my second table, which is my RC table. What it is, I will explain. Now pay attention. My columns, I'm not going to change the order of my columns. They will remain the same. I will keep it as P1, P2, P3, P4, P5. But what I'm going to change? Just the row I'm going to change. Yes, for what is my first ranked row? It is machine number 3, where I have 1 dash dash 1 dash. M3 1 dash dash 1 dash. Yes or no? Yes, which is my second ranked row. Yes, just stick, students. Yes, it is going to make all sense. Just pay attention. Okay, yes, whatever I am trying to follow, just try paying maximum attention. Yes, in the end, slowly, yes, it will all start making sense. At the end, believe me, it is going to be one of the simplest topics. That is my guarantee. But you have to stick till the end. Yes, second rank is machine 1, 1 dash 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 dash. Machine 1, which is going to be 1 dash 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 dash. Yes, third rank is M4 dash 1 1. Next, fourth rank is going to be M2 dash 1 dash dash 1. M2 dash 1 dash dash 1. Yes, fifth rank M1 dash 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 1. Fifth rank is M5 dash 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 1 dash. Is it clear, students? Is it clear, students? Have you rearranged the rows? Have you rearranged the rows? Yes, it is 1 dash dash 1 dash 1 dash dash 1 dash M3. Next we have M1 1 dash 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 dash. Next M4 dash 1 1 dash dash, next we have M2 dash 1 dash dash 1, next we have M5 dash 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 1 dash. Is this clear, students? Have you done this? Yes, everyone? Yes, no doubts till now. Let me repeat what we have done. Okay, yes, pay attention, students. For every table, we have given a name. Okay, table number 1, I have given it as CR table, Cristiano Ronaldo table. Yes, is it given by ICAI? No, it is just for our understanding to make our solution simpler. Yes, what does this CR tell? C stands for column, R stands for row. First, what we need to do, we need to give weights to our columns. Step number 1. So I have given weight to my column. From end, I have started giving binary weights. 1, 2, 4, 8, 16, 32, 64, so on and so forth. Done. Yes, next, based on that, what I need to do? Yes, columns duty is over. Next, for rows. Yes, based on the weights given, calculate your decimal equivalent. I have done this. Okay, for my row, okay, machine 2, it is using P2 whose weight is 8 plus P5 whose weight is 1, so 8 plus 1 is 9. Machine 3, which is using P1 whose weight is 16 plus P4 whose weight is 2, so altogether 18. That I have done. So two things, for column I have given weight, based on that for my row I have given decimal equivalent. Third, based on the decimal equivalent value I am getting, I am going to give rank to my rows. Third thing I have done. Fourth thing, based on the ranking I have given to my rows, I will rearrange my rows. Is this clear? So it is actually CR cube. For column we are doing one thing, that is giving weight. For row we are doing three things: decimal equivalent, ranking, as well as rearrange. Same thing we have written it down here. Look at this CR table for column weight, for row decimal equivalent. First step, we have given assign weight to your columns. That is, from last column do 1, 2, 4, so on and so forth. Based on that, calculate your decimal equivalent of rows. Say for example, we have row number 1, which is of machine number 1. Yes, machine number 1, which all parts it is producing? It's only producing P1 whose weight is 16. So yes, machine number 1's decimal equivalent is going to be 16. Yes, next row number 2, which is machine number 2. What all parts it is producing? P2 plus P5. P2 plus P5. Yes, what is the weight of P2? 8 plus P5 is going to be 1. So the decimal equivalent is going to be 9. This way we have done for every row. We have given them the ranking. Based on that, we have rearranged the table. Is this clear, students? Everybody is with me. Should we continue, students? Everyone. Okay. Now we are moving into the second table, which we have called our RC table. It is the reverse of Cristiano Ronaldo. Yes. Who is the number 1? Cristiano Ronaldo. Yes. Who is number 2? It's the reverse of Cristiano Ronaldo. Okay. Now RC table, what we are going to do? Repeat the same step, but now your columns will become rows. Your rows, whatever you did to your columns, you're going to do for your rows. Whatever you did for your rows, you're going to do for your columns. Now pay attention. RC. First, what we have done? We have given weights. Yes, there we had given it to our columns. Here I am going to give weight to my rows. Now based on that, yes, for my columns, what I need to do? First, decimal equivalent I'll calculate. Next, based on that, ranking I will give. Next, based on that, I am going to rearrange. Now pay attention, students. Yes, where am I going to give weights? Am I going to give weights to my columns, or am I going to give weight to my rows? Where am I going to give weight, students? I'm going to give weight to my rows. So here I will give my binary weights. Yes, to my rows. Yes, from where I'm starting? From last I'm starting. It's going to be 1, 2, 4, 8, 16. Is this clear? Now based on the weight that I've given to my rows, I need to calculate the decimal equivalent of my columns. Now look at this. So for P1, yes, I have machine 3 whose weight is 16 plus machine 1 whose weight is 8. So 16 plus 8 is going to be 24. For P2, I have machine 4 whose weight is 4 plus machine 2 whose weight is 2. So 4 plus 2 is going to be 6. Here it is going to be 4. Here it is going to be 16 plus 1, 17. Here it is going to be 2. Is this clear, students? Is this clear? Write it down. Yes, and finally, based on the decimal equivalent, now I have to give my ranks. Yes, what is going to be the rank, students? This is my first rank, this is my second rank, this is my third rank, this is my fourth rank, this is my fifth rank. Is this clear, students? Yes, this is my table number 2. Yes, pay attention. It is my RC table. Table number 1 was CR table. Table number 2 is RC table. What I am doing? For my rows, I will give weights. From last 1, 2, 4, 8, 16, 32. Yes, this is done. Step number 1. Next, for my columns, I will calculate decimal equivalent. Okay, for my columns, I have calculated decimal equivalent. Then for my columns, I will give ranks. And finally, for these columns, now what I am going to do? Rearrange. What I am going to rearrange, students? I am only going to rearrange my columns. Rows I will keep same. My columns I will rearrange. Is this clear? Now quickly write this down. Pause, write it down, and then rearrange your columns and prepare your third table, students. Yes. Now we need to move to the third table, students. Yes, from now on things have become very simple. Yes, table 1 is over. Table 1 is my CR table, Cristiano Ronaldo. Table 2 is going to be my RC table. So what is going to be table 3, students? What is going to be table 3? Table 3 is again going to be my CR table. Is it clear? So all your 1, 3, 5, 7, 9, 11, 13, 15 till wherever it is going, all those will be your CR table. That is, for your column, you will give weight. For your row, you will calculate decimal equivalent, give the rank, rearrange. All your 2, 4, 6, 8, 10. Yes, that is going to be your RC table. That is, for your row, you will give weight. Based on that, for your column, you will calculate decimal equivalent, rank, and rearrange. Is this clear? Now we have a third table. Yes. So from my second table, I need to rearrange things, students. Yes, based on the ranking, I need to rearrange here. Yes. So here, what I am going to rearrange, students, I am going to rearrange my columns. So my columns I will rearrange. That means my row will be constant. So I will write M3, M1, M4, M2, M5. 3, 1, 4, 2, 5. So it will be 3, 1, 4, 2, 5. Yes, be very cautious, students, while you are copying the data from one table to the next table, because one mistake and your complete question, all your efforts will go for a toss. So do not hurry here unnecessarily. Yes, keep your concentration, do it very slowly. So first rank is going to be your P1. Yes, if you are taking extra time, it is fine, but do not commit an error. Yes, 1, 1, dash, dash, dash. Second ranking is going to be my P4. What is the number? 1 dash 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 1. Third ranking is my P2. Dash dash 1 1 dash. Dash dash 1 1 dash. Fourth ranking is my P3. Dash dash 1 dash dash. And fifth ranking is going to be my P5 dash 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 1 dash. Yes. Have you rearranged, students? Have you rearranged? So now we need to repeat the same thing. Which table is it, students? Which table it is? Yes, it is my third table. So CR table, RC table, again it is going to be my CR table. What is CR table telling? Yes, first give weights to your columns. Okay, I will give weight to my columns. Yes, from last 1, 2, 4, 8, 16. Okay, give weight to your columns. Based on that, for your row, do three things. First, calculate decimal equivalent, then give the rankings, then do your rearrangement. Is it clear? Yes, write it down for every table. Yes, I would suggest you compulsorily, either you write it in your pen or in your pencil, it is fine, but do this thing, students. Otherwise, there is every probability of you making a mistake. Okay, okay, for my columns, I've given weight. Okay, done. Next, what I need to do? Go back there. Okay, for my rows, I need to calculate decimal equivalent. Okay, for my rows, I need to calculate decimal equivalent. Okay, here. Yes, it is 16 plus 8, 24. Yes, it is only 16. Yes, third one, it is going to be 4 plus 2, 6. It is 4 plus 1, 5. It is 8. Okay, decimal equivalent is over. Now, for my rows, I need to give rank. Yes, tell and do it so that you don't commit an error. Okay, 1, 2, 3, 4, 5. And finally, now what I need to do? My rows, I need to rearrange. My rows, I need to rearrange. That means my columns will remain intact. My rows, I am rearranging. Yes, columns P1, P4, P2, P3, P5. 1, 4, 2, 3, 5. Now my rows I need to rearrange. Pay attention, students. First one is M3, 1, 1, dash, dash, dash. Second rank is going to be M1. It is 1, dash, 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 dash. Third ranking is M5, dash, 1. Fourth ranking is going to be M4, dash, dash, 1, 1. And fifth ranking is going to be M2, dash, dash, 1, dash, 1. Yes, is it over, students? Yes. Now we have our fourth table. So first table, what was it, students? Yes, CR table. Second is RC table. For every table, give these numbers. Believe me, otherwise 99% students, yes, are going to commit yes small silly errors. So give the names. Table 1, CR table. Table 2, RC table. Table 3, CR table. Table 4, again, it's going to be our RC table. What does RC table mean? Yes, first for my rows, I'm going to give my weights. Okay, based on that, for my columns, I'm going to do three things: decimal equivalent, ranking, as well as rearranging. Okay, for my rows, okay, rows, I'm going to give weight. How am I going to give weight? From last 1, 2, 4, 8, 16. Yes, for my rows, I have given weight. Based on this, for my columns, I have to calculate my decimal equivalent, give ranks. Now look at this. So for P1, 16 plus 8 is going to be 24. 16 plus 4 is going to be 20. Next here, 2 plus 1 is going to be 3. It is going to be 2. It is going to be 1. Yes. What is going to be the rank, students? What is going to be the rank? Rank is going to be 1, 2, 3, 4, 5. Yes. Did you get it till here? Till here, any doubts, students? Till here, any doubts? Till here, any doubts, students? No, till here things are clear. Yes, with this, the question is over. How do we get to know the question is over? Yes, how we were going to rearrange, students? Here we had to give the rank. Based on the rank, we had to rearrange. Now, what is the rank I am getting? The rank I am getting is already in order. See this, 1, 2, 3, 4, 5. So even in the next table, if I rearrange, it will be in the same order. So there is nothing more I need to do. Now if you pay attention, yes, all the machines as well as parts are already arranged in a row. Now look at this, students. Yes, to produce P1, what all we want? We want machine 3 and machine 1. So this we create in the form of one cell design. Again, we also produce our P4. Why? To produce P4, I want M3 also. I want M5 also. Is this clear? This is going to be my cell 1. Yes. Again, next you see, to produce P2, you want M4 and M2. Okay, based on that, you can produce P3 also. You can produce P5 also. This is going to be your second cell. Yes, clearly things are visible. Yes, based on this, we have bifurcated things. So now we can write our solution. Finally, as the ranking is neatly arranged in order, we can stop the process. Now cluster number 1. Yes, this is my first cell or first cluster. What all machines I am having? M1, M3, M5. M1, M3, M5. Whatever the order, you can write it down. Yes, if you want, you can write M3, M1, M5 also. Yes, again, don't question me over that. I'll write the same order. M3, M1, M5. Yes, what all are the parts that are getting manufactured? P1 and P4. And next, you have the second cluster, second cell, where we have two machines, M4 and M2, where we are manufacturing three parts, P2, P3 and P5. Was this the same answer that we got logically? Was this the same answer that we got logically? Now let's have a look at that answer, students. Yes, what was the answer that we got? Cell number 1, we are producing P1, P4. Yes, for that we have three machines, M1, M3, M5. Correct. Cell number 2, we are producing two products, P2, P3, P5. For that we have two machines. Same answer we got here. Yes, if you want. Yes, look at this. Cell 1, P1 and P4 we are producing. Yes, we have three machines, M1, M3, M5. Yes, M3, M1, M5. Cell 2, we are producing three products, P2, P3, P5. P2, P3, P5. We want two machines, M2 and M4. M2 and M4. Yes, did we get our answer, students? Did we get our answer? Yes, with this rank order clustering algorithm is over. Is this clear, students? Any doubts till here? So now let us write down the steps properly. First we will write down the steps properly. Yes, so that you don't forget the things. Yes, what is important, students? Firstly, yes, we need to give name to our tables. Okay. Firstly, the main thing for us is to name our tables. What we are going to name our tables, students? Yes, all our table, odd number tables, table 1, 3, 5, till whatever it goes. We are going to name it as, yes, who is number 1? Cristiano Ronaldo. So it is CR table. Yes, what does this CR table stands for? Yes, for my column, I need to do one thing, which is give weights. Yes, assign binary weights. And for my rows, I need to do three things. What are the three things, students? Yes, write it down. What are the three things I need to do for my rows? Yes, firstly, I need to calculate my decimal equivalent. Okay, point number 1. Yes, next, I need to give a ranking based on decimal equivalent. And finally, I need to rearrange. Every time you are doing, yes, write this down and only based on this do, students. Otherwise, there is every chance for us to commit an error. Yes, I've explained you logically, but every time you are going to do, yes, you are not telling to yourself what you are doing. There is every chance. Instead of column, you will do for rows. Yes, you are going to jumble up. So every time, whenever you are solving this question, be extra cautious, be extra slow. Yes, you will get the answer right. There is no chance for you to lose even a single mark. Okay, then we have our table 2, 4, 6 onwards. What we are going to call it is the reverse, that is RC table. So I can tell RC. Yes, for my rows, I am going to calculate my weights. Based on that, for my column, first I will calculate my decimal equivalent. Yes, based on that, I will give the ranking. Based on that, I am going to rearrange my columns. Yes, once you know this, the question is in your hands. Okay, once you remember Cristiano Ronaldo, everything else is in your hands, students. So now, yes, let's see the proper steps. Okay, so the steps to solve the question. Yes, step number 1, assign binary weights. Yes, what are going to be our binary weight, students? Binary weight is going to be 1, 2, 4, 8, 16, so on and so forth. If you want here, you can write only for your purpose 2 to the power 0, 2 to the power 1, so on and so forth. Now, order of assigning. What is the order of assigning, students? It is going to be reverse. It is the reverse order in which we are going to assign. What is this reverse meaning? We have columns. Yes, we have these columns. Yes, these are my columns. Where I am going to assign? Am I going to assign from left to right or from right to left? How am I going to assign for my column, students? How am I going to assign? Yes, from left to right or from right to left. It is going to be reverse order. Generally, we write from left to right. But here, when I am going to assign, it is going to be right to left. Yes, in case of rows, yes, these are my rows. Am I going to give from top to bottom or from bottom to top? It is reverse. So I am going to give from bottom to top. Yes, this is step number 1. Yes, I need to assign binary weight. Is this clear, students? Yes, once I have assigned my binary weight, I need to calculate my decimal equivalent. I need to calculate my decimal equivalent. Yes, how we are calculating decimal equivalent based on the binary weights? That in our first and second table we have shown. Okay, if you have machine P1, P2, all of that practically also we have written. So calculate decimal equivalent. Based on that, give rank to your decimal equivalent. Yes, the decimal equivalent having the highest value will be given first rank. Okay. Yes, next what we need to do? Rearrange the table based on the ranks. Yes, and all of this we need to do. How we need to do this, students? Yes, first we need to do it for our CR table. Next we need to do it for our RC table, and so on. Yes, your key here, if you want to get the answer, very simple. See, we have explained the steps, everything. Yes, let me summarize everything, students. Yes, table number 1. Yes, CR table. Just remember Cristiano Ronaldo. Table number 1 is my CR table. So first I will copy the data from question, write it down. Yes, this is my table number 1, CR table. What is CR table standing for? Yes, column, row. For my column, I am going to assign weights. Okay, I have assigned weights. Yes, for my columns, I have assigned weight 1, 2, 4, 8, 16. Yes, based on that, for my row, I am going to calculate decimal equivalent. Okay, I have done for my rows, I have calculated decimal equivalent. Based on that, for my row, I need to give rankings. Okay, I have given the rank. Based on that, for my row, I need to rearrange. Yes, that I have done. Yes, next, second table. Yes, it is my RC table. Here what I am doing, students? Yes, R. For my row, I am going to assign the weights. Yes, for my row, I am going to assign the weight 1, 2, 4, 8, 16. Now, for my row, I have assigned the weight. Now, based on that, for my column, I have to calculate decimal equivalent. Yes, now for my column, I need to give the ranks. Based on that, my columns, I need to rearrange. This one, I keep continuing till where, students? Till the time, yes, I reach to a point wherein the rank is neatly arranged. There is no need for me to prepare the next table. Yes, finally, in my fourth table or something, I got my ranking was 1, 2, 3, 4, 5. That time I realized, yes, the story has come to an end. Now I see, yes, whatever it has arranged, yes, it will be automatically arranged in the form of clusters. All I need to do is identify that clusters at the end, right? Cluster number 1, which all machines are required, which all parts are produced. Next cluster, which all machines are required, which all parts are produced. Is this clear, students? Any doubts in this one? Yes, believe me, students, this could be one of the most likely questions in your examination. I have never told this question is important anywhere till now, because I believe everything is important. But because this is a newly added concept, because it has come in our RTPs 1 to 2 times, and because it is slightly an interesting and a different concept, there is every likelihood that ICAI is going to test you. Okay, so better be prepared with this one properly. Now, yes, there is no, see, if I have to tell you one thing, okay, straight away from my heart, okay, now ICAI has followed, yes, giving the weights. ICAI has given you the weights. Yes, what it has done, first it has given weight to column. Yes or no? CR table, first we have assigned weight to column. If we assign weight to row first, will we get the same answer? Try it by yourself. We should be getting the same answer. Again, while we have assigned the weights, what we have done, from last we have done 1, 2, 4, 8, 16. If you do from first 1, 2, 4, 8, 16, should you be getting the same answer? You should be getting the same answer. But In exam, what we are going to do, whatever ICAI has done, same thing we are going to do, students. We are not going to change the order anything, because ultimately we want every steps, every table to match with ICAI. So I am telling you, yes, logically, whether you do CR table first, RC table first, it shouldn't matter. Logically, whether you do reverse, you do from start, it should not matter. You can try it by yourself. But in exam, what we are going to do, we are going to follow the same way ICAI has done. It is CR table, RC table, CR table, RC table. Now coming to, yes, small logic. Okay, again I'm not going to give you proper in-depth, because see, it's an engineering concept. Yes, it requires too many things, but simple. Okay, just looking at what we are doing. Okay, yes, if we can derive some logic from this. Now pay attention, students. This is the data of the question. Okay, now what I want to produce my P1, I want machine number 1 as well as machine number 3. Yes or no? So these two machines should be together. Yes or no? So here what I am doing, I am giving weights. While I am giving weights, I am giving maximum weights, yes, to the machines which are producing P1, so that they become together. At the end of it, what happens automatically? My machine 3 and machine 1 is together. So these have automatically formed a cluster. Okay, similarly I go on doing, so that yes, wherever whichever is required together I arrange, whichever is required here I arrange, again I keep doing, again I keep doing, again I keep doing, so that finally it reaches a stage where all the things are neatly arranged. Just a simple logic. Okay, it's not a pure logic, just a simple observation of, why we are giving the assigning weights this way. Okay, is it clear, students? Yes, any doubts in this one? Yes, should we continue? Yes. Now, yes, it was the concept of ROCA. Now, same concept of ROCA. If you see what ICAI has done, yes, ICAI has unnecessarily complicated, yes, putting all these formulas, yes, all the formulas which we are running away from, yes, ICAI has put all of that together. Yes, DJ is equal to summation of BWI, yes, AIJ. Yes, we have done without using any of those technicalities. Pure, simple logic we have done, students. Now, we have one question. Yes. Test your knowledge, question number 8. Okay. Now, here what we need to do, what is required, students? Okay, 3 things are there. Yes, first, discuss the concern explained over utility of cellular manufacturing. Explain on utility of at least 3 cell machines, at least 3 machine cell designs which can be used, and use ROCA. Yes, for ROCA, if you look at this, it is the same data which we have used. Yes or no, students? It's the same data, just that here the numbers are different. I have made it simple, telling 1, 2, 3, 4, 5. Here also the numbers, they have made it different. I have used 1, 2, 3, 4, 5. Yes, so it's going to be the same answer. So it is going to be a homework for you guys to try solve it by yourselves. Okay, finally we are getting the same answer. If you see two parts in 3 machines, 3 parts in 2 machines. But you see ICAI every place, see, it has complicated the solution, and it's not that we are having marks for writing this. It's not even making any sense. Okay, yes, we have done it in a much simpler way, believe me, students. Yes, same thing without, yes, this is our binary weights, this is my decimal equivalent, based on that it is the rank. Okay, everywhere they have written this down. Yes, D is equal to that, this, yes, all of that is not required. Straight away, yes, you can come, you can give your heading table number 1, CR table. Yes, for your column, assign weight. Based on that, for your row, yes, calculate decimal equivalent, give ranking, rearrange. Continue. Yes, is this clear, students? Now, with this, the concept of rank order clustering algorithm is over. We have 1 or 2 additional points which has to be kept in mind, which we'll see along with the questions. Now we'll take a break of 15 minutes, students. It is 7:47, 8:05. We will continue the session. Thank you so much, students.